sound is there. I still couldn't find the animated one that I was doing. I was looking at. Oh, okay, this one. Yes. So today, because of the condition of whatever creative coding, that's what we call it. It is a challenge of coding anything you want, a game, a visualization, whatever you want. But some of us are beginner to this, so we would like to give you a quick session on how simple it is to just get started and draw stuff, animate it, get something cool, and then probably win a prize if somebody selected your work. So there's a lot of these kind of thing. They call it generative art. It's not AI. It's generated by a computer program. That's the idea. So there's probably more. There's something like this. It's pretty sick. There's a lot of things you can do. So that's why we. Sorry? Game of life. Game of life is an interesting one because it's not here. Conway. So you have this grid is a grid. Then you start off with some drawing, and then each of those cell in the grid follow some certain rule. If there's more neighbor than 4, it kill itself, it die, and if there's less neighbor, it's born again or something. That's the idea. And then if you draw it out, there complex behavior happen after that. So you could generate like a spawner, something that flies, something that built something else, something that built a structure or something like that. That is the idea. So there's a lot of things you can do. If you are interested to explore any of these, this is the time. Like, not exactly the time, you have exam and all that, but it should be something to kickstart for you to get going and then explore more. So I'm gonna increase my font, maybe not too much. And I want this to be a very interactive one, whatever idea you have right now, because for now we're just gonna build something simple, and I think flow fill is a simple enough thing so we can. What was it again? Oh, yeah, it's so hard to look for this. I just found it. But yeah, whatever idea you have along the way, just pop it in, and we try to see what we can get. We don't want to do replicate this exact thing. We want to see what can we get out of it ourselves, right? So this is what we call flow fill. Each of those spots on the place has some direction. So wherever a point comes in, it redirects the point, and that's why you can see the point just flow around. That's the idea. First of all, I'm gonna introduce the tool that we're gonna use. You can use anything you want, but this is the simplest one, and it's very easy to get started with. You have this function that whatever code you put in, it's get called once. So here you set up a canvas of 400 by 400. This function will be called again and again and again forever. And here it's just gonna draw a rectangle on your canvas with that color 220. So if I run, I could turn this on. That's the canvas with that color. And if I 0, the canvas turned black. So P5JS allow you to do a lot of things with it. Let's say I can draw a circle, 0, 0, with the radius of 100, and it draw me a circle on the top left. And if I know the width and height of the canvas, I can draw it at the center. It will be at the center. Now, instead of just draw it with a specific point, we can create a variable, let's call it x, and we will use that. Nothing's happened, but now we can say x++, and it should move the circle. And the reason is because we clear the canvas, we draw, we update. Clear, draw, update, clear, draw, update. That's the idea. So whatever you have, you can do it with just this simple stuff. So P5JS have a lot of utility that you can use. Draw a rectangle, circle, do some math, whatever you want. It's very neat. So I never done flow field before. So I'm excited and I don't know how to exactly start.
Let's look up Berlin noise. What is Berlin noise?
Okay, Berlin noise then. I thought we don't have to get into this, but here we are. Wait, P5JS noise, is that?
Yeah, it uses Berlin by default.
Okay. So you can create some random function, random value basically, with specific time and give you that deterministically. What I was thinking is that what if we just start figuring out drawing the vector out as a grid first. So for each of this, we divide a specific number of row and column. So row, let's say 10 row, 10 column. And after that, are we doing P5JS, Berlin noise? After that, I want to draw a bunch of dots on that point so that we can visualize our vector field later. 0, I less than number of row. You know what, let's do this. Rows, columns. Rows start from 0 and go all the way to a bunch of rows. Are incremented. Would have the same thing again, this time for columns. Now we look through a grid, but we need a way of distant, like make them, I don't know, to like make it like a square. I don't know what I was saying. Anyway,
I'm plotting a point for each value of R and C.
Sure. Let's draw a simple.
Actually, yeah, go
Yeah.
on.
Oh no, row and column. Let's go. We have to deal with X and Y.
Yeah.
So row is Y.
Row is Y.
Column is X.
Yes.
And I can draw a point at that point. X and Y.
Just won't do anything.
Because we just go through 10 and from 0 to 10 and it's very, very small. 0 to 10 is like top left and it couldn't see anything.
Yeah.
So what if I multiply this by a certain number for now? Wait, do I have to fill? I just draw a circle.
Yeah.
Okay.
There we go. Yeah. So what would we have to multiply it with in order to make it evenly spread out?
Yeah, that is a question that we have to deal with. So
Yeah.
each of this, it spread the point vertically and horizontally, but we don't want to just spread it random number. We want to spread it evenly so that all the points stay in the screen nicely without overflowing. So this spreading basically the distance between each point, and if we know that the whole screen is 400 and we have 10 points, the distance will be 400 divided by 10. So we're gonna do it here.
But you can use the predefined keyword width and height. That gives you the width and height of the canvas.
I could do that.
Yeah.
What I could do is create a variable for that.
It is a variable.
No, not just width and height, but like gap X. I don't like using let gap Y. And in setup, we can say gap X is equal to width divided by
Lowercase. Yeah.
number of columns.
Yeah.
gap height divided by number of rows. That means instead of just multiply with some random number, we multiply with the proper gap value. Now all the points should stay there, but we start from 0, that means all the 0 points. So we could offset this. The idea of the offset is that you shift it by some value. So rows divided by 2, maybe? No, that's not right. Gap x divided by 2. Probably. Gap y divided by 2. So now everything is in the center. And the cool thing is that now we can increase this to whatever we want, 50, 50, and you got all of your circle. The radius can be decreased to 5 now. Yeah, my computer is dying. Yes, let's just go with 20 for now. Okay, so we have a bunch of points. Not exactly point, we just draw a bunch of points and nothing's happening. And a good thing we could do right now is to, because we want that each of these points have a direction on its own. So if I pick a point and know some direction, it doesn't matter what kind of direction, I just know it's pointing somewhere. So we need to store those directions somewhere. And the simplest way is to just create an array for that. The 2D arrays. Let's call it fields. Field is equal to a 2D array. So we're gonna create some random direction. Wait. Yes, so to store direction, we want to use something like a vector. Like how much it's point up, how much it point to the right. And any value between those two give you the direction in circle. And all of them must add up to 1, so that it's not too far, it's just a normal direction in a way, right? Or you could use something like an angle value, right? Like some degree, 0 is right. Do we want to use a angle?
I think vector is probably better because vector will tell us how far in a direction a point is being influenced. Right now, I think the easiest thing you could do to move these points around is while you're adding the offset, instead of a constant offset, add some noise. And now the points will be animated.
Oh, that's a good point.
Right?
I could generate a noise. Again, we're not trying to replicate anything, we just try to see what kind of thing we can get out of this.
Noise accepts 3 parameters, x, y, and t. So this will give you one single offset value. So as the third argument in noise, add frame count.
Yeah, it's a time. Frame count basically tells you what time you are at. So from the beginning of the universe toward right now. So each of this call will have a different frame count. So it count 1, 2, 3, 4, 5.
Does it start counting from the beginning of the program?
I think so, yeah. Let's see.
Frame count. Since the sketch started.
Okay.
Now it is.
Oh, it's shaking.
Jittering. It is moving. Very, very slightly.
Multiply the noise.
Let's amplify the noise.
We want. Okay, let's just 0 to 1.
0 to 1 is the x and y value. That's not the range of the noise. That's
Oh.
where in the noise graph you are.
Oh,
So it will give you 1 decimal value.
I see.
Amplify that by like 10.
I could use the x that we have.
Yeah. So now it will be different for every point.
I see.
Right?
Something.
And now multiply that noise with
yes.
10.
Yes. Okay, let's call some variable.
Yeah.
Amplification.
Amplitude.
10.
Yeah.
What's going on? Mac Master. You got in? Okay, the code is very disgusting right now. If okay, this is a bit cleaner. This is the radius. Multiply with this. Multiply with this. Oh, look at that.
Yeah. Now we want to make it slower, so let's divide the frame count.
Okay, I'm just gonna multiply with 5.
It'll still be very jittery.
What does frame count do in noise function?
Frame, so noise, it might be good to demo this or just talk about it. Is there a graph or
Okay,
a
we got.
marker?
Yeah.
This. So
Get some random
noise
thing.
works like random noise works like this. If you have 0 and 1, right?
Another
and
thing we should
given an X
consider.
and Y value, the graph of your noise will look like this. That's noise. So if you give it an X value, it will give you a corresponding Y value, right? And that's 1D noise. What this uses is 2D noise. So for a given X and Y value, it gives you a very jittery looking plane. And then for a given X and given Y, you will get the corresponding noise value, like random. What noise does specifically is instead of this really jittery curve, the curve you get is much smoother. That's the difference between random noise and Perlin noise.
And another thing about Perlin noise that you can determine, like if you give the same value frame count, it gives you the same noise.
Yeah.
It's not exact noise like predetermined noise. It's deterministic noise.
Yeah.
Like the dot moves in a pattern.
Yeah.
Yes.
Yeah. And sorry, another thing like let's say Minecraft terrain, right? It's just a noise generation, and if you put the same seed, it generates the same terrain. That's the idea.
Yeah. So what we're doing here is from this 2D plane of Perlin noise, we're picking one point at a given time and getting the 0 to 1 value at that point. And then, so what our like 2D Perlin noise looks like is X and Y, and this is the noise value. You have this really smooth but noisy plane that corresponds to it. We get an X and a Y, sample it, and then as time changes, this value changes just a little bit, and then just a little bit. If it was random noise, it would change drastically. So we make this change a lot smaller by dividing the frame count. Just so this change from this X to this X, or this point to this point, is very smooth. And that way it means smooth looking animations. And all of it is like random. So every time you start it will be seeded with some random value. You could probably seed it yourself.
Okay, we kind of get off track here.
Yeah. So we got some points on the board and we made them move based on randomness. And we can control the randomness by these 4 factors. X and Y, which is different for every point. Frame count, which is the same for every point. So all of these points move by the same rate. You can make them move with a different rate if you add these here, right? If you noise the frame count, exactly. You can add whatever you want to this, like use these variables, whatever. You can make the amplitude dependent on where the point is, right?
Yeah.
And so X increases that way, and Y increases that way.
Yeah.
So if amplitude was dependent on X and Y, the points at the top left will be very slow and very low in amplitude. But the points over here will be much faster because
Alright, let's
it
do that.
increases
Let's do that.
linearly down that way. It's very cool to like you mess with it, it gives you something, and then you try and figure out why that's happening.
Damn it, my weekend.
Yeah. Yeah, see?
So all the ones on the top left, like top side and on the left side are
Very close to 0.
yeah, they're close to zero.
Yeah.
I see it.
Okay, but I still want to do something related to
Yeah,
this.
let's do flow fields. We're,
Yeah.
we're much closer to this now.
Now we
than
can
were at the
generate
beginning.
some noise.
You can?
Fractal. I don't know how to do fractal, but we can try think on something. But anyway, I think what they do is that they pre-generate the vector field so that you don't have to redo it again and again. The noise start off here. So up here, this is where you generate a grid of direction, and you store that, and then you use that later. What we're doing here is just moving the point around, experimenting with this noise function that gives you some random number. So we can ignore drawing for now and dealing with generating the field itself. We have this field variable as a array, but there's nothing in there, so we would like to initialize it right now. So the way we initialize it is just going to be for loop through all the point in our grid, and then in between we create a temporally array, and then with that we can put something into it. So dot append some value, and then at the end we can say field dot append temp. Yeah. Okay. Appending, this is where we have to figure out what kind of value we want for each field. We can represent it using a vector or an angle, and I was thinking a vector is good. Okay, let's do vector.
Vector
Yeah.
is simple because you can just add it to each of the corresponding
Sure.
values.
So
Just
how do we
like that.
generate? So vector gives you two values, x and y, but since it is a unit vector, you have to deal with normalizing it anyway. Do you think what if we just generate an angle
Sure.
and then we convert it to a vector?
Sure.
An angle like between 0 and 360. So I'm just gonna do it now. Noise 0, 0, 0.
Angle from the top left, right?
Sorry?
Angle from the top left.
Wait, this value will be, so this value, the noise that you get will be between 0 and 1, right? It is normalized already.
Oh, really?
Yeah.
Wait, but
So you map it between 0 and
it gives you a
5.
single number.
It gives you, yes.
Yeah, and if you put them together,
Yeah.
the whole vector is not normalized anymore.
Mm.
Well, let's do that. Let's do that instead. Angle is a bit confusing. It's con x is equal to noise. How do we deal with this? What's x and y? I could just put x and y then. And then 0 as the initial frame or something. V x.
X is
Sorry?
So this will give you the same value, right?
Yeah.
So what we can do is offset y.
Oh.
This would, yeah, so the third value still needs to be, if you want it to be animated, you can do frame down. But yeah, you can not offset y, the vector y. So just add 1 to the 0 there.
Are these three parameters in noise just
No,
numbers that are
not there. Replace the 0 with the 1. So now the noise value of vector y
Oh.
will always be 1 ahead of the noise
Yeah,
value
yeah,
of
yeah,
vector
yeah.
x.
But 1 might be a bit too close.
1 might be a bit too close, yeah. So add like 100.
Okay. Now we have this vector. It's not exactly vector yet. Yeah. So we can use this. First of all, we want to normalize it so that the vector. Well, anyway, let's just put this in our drawing and see what's look like, right? So it is a 2D array of 1D array. Wait, P5 has a thing called vector. P vector, I think.
Yeah.
Give me the vector. Sorry. P vector.
Well, that's processing.
That's-
P5 is just called vector.
Okay, let's just trial and error it out. That way we could do some math to it without having to
Yeah.
write the whole thing.
It's called vector.
Oh,
Uppercase V. Yeah.
nothing come out though.
Yeah, it's that one.
Oh,
Put in the first.
Yeah.
Create-
Oh, create vector.
create
yeah,
vector.
Or new P5 dot vector.
so we're gonna put in vex x, vex Why? This feel like coding train. This is like dream
Yeah.
come
Yeah.
true. Finally, I am him. But yeah, we got our field, and obviously we're not gonna print it out because we are not a normal programmer. We're gonna draw it out, see what it's look like. For now, it was just a circle, but to draw a vector, we want something like a line. So I think what we could do is draw a line from x and y where they are, and then x plus. This is where we have to access our field.
Yeah.
So first of all, let's access them. Our field can be accessed by y first, then x.
Yeah.
Oh man, this is, and then assign it to a vector variable. Then we can say vec.x, vex y plus vec.y, I think. Feeling weird without Vim.
Vec.y. 37.
The error is always on the wrong.
What is it?
Oh,
Isn't
push.
it push? Yeah, that's what I was wondering.
Yeah, it's not Python.
Yeah.
Alright. Nothing comes out because we don't call stroke.
Stroke weight as well, maybe.
Oh yeah.
Call it before the line.
Really? Wait. No. What's happening? Okay, let's do it. Line.
This is right.
Oh, it's called before drawing. So you
Yeah,
have
it's
to.
called in setup.
That's weird.
Still no.
Hmm. Stroke and then stroke weight. Is the math wrong somewhere?
What?
Is the math wrong somewhere?
Let's see. For every row that you have, you make a temp. What is field? Where is field initialized?
Up here.
The field is an empty array that contains.
Okay, I cannot go without printing. Let's do it. Give me the thing.
There we go.
It's a nan.
Number for the third parameter. What is it? If I just line.
Oh, because our field might generate a nan number somewhere.
So just do like if it's nan, it's 0.
Can you check what vec is?
Let's check this first. It's a class.
Okay, that's the vector.
It does have. Oh, wait. I think it's just lowercase x and y. That might be. Oh,
Yeah.
Okay.
See it, yeah.
we got it. We got it. But our x and y is not just x and y because x and y is not x and y.
Yeah.
So
So what you can do here
call it
is
row again. Then we offset it later to x and y,
okay.
so that we don't have any variable conflicts. Rows and column.
Yeah.
So bad. Now our x is equal to row multiplied with gap x plus, oh, we don't have to.
Yeah.
Y is equal to column multiplied with gap y.
Can't you just do this in the for loop?
Sorry?
Yeah.
Instead of r plus
Yes.
y.
Yeah. Now our field can be accessed using row and column. Okay. There's something there. Couldn't.
We might want to increase the length of the line.
Oh, the vector is only so small, so we want
Yeah.
to increase the multiply our vector a bit. So P5, if you put everything into a vector, you should be able to use their operation like multiplication directly onto the vector without having to do it individually, right?
Or you could amplify the noise in the initial calculation.
We could. I just want to
Yeah.
introduce this
Just
idea.
multiply another character.
Sorry? Mult, let's go.
Yeah.
Yeah, beautiful. So this field R and C give you a vector, so we can just call mult directly on it, and give it 5. Wait, is it mult by?
There's your 1 point next to.
Oh, it's in place. It's multiply and it put back the value. That means if you keep multiplying it, it's gonna keep going forever.
Ah.
Oh, how do you? Oh man, that's not right. I think we can use their built-in instead, their static instead. So instead of dot mult, we use vector dot mult by some value. Again, we need to figure out what the actual vector
I
is.
don't think vector dot point is a thing.
No?
Alright, it's p5 dot, you have to specify p5 dot vector.
I see.
Lowercase p. Yeah.
Yes.
Now we have a slight difference. I think maybe lower the stroke weight.
Okay, we
Yeah.
got something. How about we multiply even further? We just like to keep everything 0 to 1, and then whatever we want to visualize it, we do it later.
Yeah.
That's the idea. Alright, so summarize this a bit. We generate a grid of vector, and vector is just a 2 number that gives you direction, and that grid contain those vector in there, and the vector is randomized. Now we got all of these looking weird thing, and then we draw them. Now, I don't really like the way these vectors look because it doesn't have the flow in them. Some of them just immediately turn 90 degree. But if we start visualizing the dots flying around, it will start.
What if,
Yeah.
instead of drawing a line,
Yeah.
we draw a circle or a point whose opacity or thickness depends on the length of the line?
Could, but then it's just a random point, just a point with random opacity.
Is it?
Yeah, because
It's Berlin, so there will be a gradient.
yes, but we're not actually using. Oh, we do use, but it's offset. We could do that. Let's do it. So circle at x and y. Radius. How about radius?
Yeah.
So instead of just drawing a line, we're not getting into the goal yet. We're just trying something again. Let's call it radius is equal to.
Don't use our.
Wow. Yeah, bad naming convention. Dot magnitude. Yeah, that's cool. Radius. Okay.
Totally cool.
Okay, I can save this and upload it.
Yeah.
Alright, I'm gonna upload it once so that at least we have something. Bang. The submission, what do you think about submission? How do we want
How do
people?
you do it?
Just, can we save it? Can we share
I
it?
mean,
The script should
you
generate
can
the same.
save it.
Okay.
The
Yeah.
script should generate the same
Yeah.
slash animation.
Yeah, they can either upload the whole code or I think P5JS allow you to share the whole editor. So you click on a link and then
Yeah.
some like that. I don't know. But yeah, whatever you want, we kind of go too easy. But yeah, this is just one example. Now we could try to go back to our original idea, so that we're not just drawing random thing and
Yeah.
think it's look cool. We actually have a goal, and that goal is this thing. Just to remind everybody. But yeah, let's draw the line again. What I want to do now is we could drop a point and see how does it fly. Right? So I'm just gonna do this. I'm gonna call x equal to 0, y. We could create a point class, but this is fine. It start at a corner, and then all of these vectors seem to just flow in this direction. It doesn't go somewhere else.
I mean, some of them might be pointing the other way. We just don't know where it starts. and ends.
Yeah.
None of
Yeah.
them point that way though.
Point which way? Like.
Oh yeah, another
Oh,
left and down.
yeah.
That's weird.
I
Anyway.
think it's because X and Y. So
We can
maybe
tweak
we
that
don't have
later.
X and Y, right? So X and Y are always positive. So the point will always be in the positive quadrant.
Very true.
Anyway, we will tweak that later. Now to draw the point, the reason I create X and Y here, oh no, that's not a good idea. Let's create a class. Do we have a point class or I need to create one?
There is a point class.
I don't think so. There's only a way to draw, but no point.
Let's just use a vector.
Yeah, vector, let's do it.
A vector is a point.
Let's call it point.
Yeah.
Is a create a new vector. Starting 0, 0, or maybe in the center. So 200, 200. And we cannot call it from there probably.
How are you thinking of animating it?
Hold on a minute.
Yeah.
I got an idea. Create a vector is not defined out here, so everything has to be done in the setup just to make everything cleaner. So I'm gonna create a point outside.
Don't call it point.
Oh, P. A point.
A point.
Okay, a point. Here we go. Let a point outside. That's weird. We initialize it here. The point should start at the center. And the idea that I want to do right now is that we draw the point, then we update it based on where it is on the screen by the vector. So whatever the direction of the vector is, we add
Yeah.
something like that.
So I think what could be cool is in draw, so every time you update, get the position of the point, get the corresponding vector for that point by the, like if you floor the index or
Yeah,
floor,
oh, I
the,
see,
floor
I
the
see.
position, get the corresponding vector at that point and then just add it.
Yeah. Although adding just the position would just skip the point would just jump around. I would do velocity so that it goes smooth. You know?
Or have more points.
And the vector act as a acceleration. In a way it's like a gravity. So thing don't just goes in a constant speed, it just starts slowing and then speed it up or something. So it might be more interesting. So the velocity should start 0. There's no completion. That's weird. Zero, 0. Now our point, we have to update its position. So it's equal to, we could just say dot add. Does it have dot add?
Well,
A point velocity.
there is that.
Okay. Now I'm just gonna draw it a point circle at a point dot x with the radius of 10 called fill onto it. So let's 255. And then I'm gonna lower the opacity of all the line. Okay, we got something.
Yeah.
No stroke. You have to do it first, that's weird.
Do no stroke,
No, it's fine, it's working.
yeah.
So, yeah. The point started at the center, it's there, nothing's working, nothing's happening. What we need to do now, oh wait, should have add. There's no add?
Well, there is that. No, you're adding a point velocity which is 0, 0. We need to update the velocity.
Oh, yeah, my bad. Anyway, now what we can do is a point velocity is equal to the vector add the vector field, the vector in the field. So wherever the point is, sorry,
Yeah. Is that noise?
noise? No.
With randomized velocity information.
We
But
could
don't
try.
want that. We have a field based on which we want to traverse, right? So wherever the lines are pointing, we want the circle to follow those lines down in a smooth way.
So if you imagine 100 points, like this one,
Yeah.
it just flow the same way because of the field,
Yeah, you use noise, it's one of the field.
right?
We'll see.
Okay, let's do it. I see the noise, but the point is gonna flying around.
Yeah.
Is it gonna be jittery? Like, how does that animation work?
Yeah, let's see. The noise alone might be jittery, yeah.
We might have to upsample the number of points that you have.
Yeah, yeah. So how do we get the vector?
So you take where the point is, right? And then get the vector at that point.
So I don't know
So
the
you
x.
have fields, right?
I have this x and y.
Yeah, so fields at a point dot y and a point dot x.
I could floor this though. I must. But
Not even just for we need to, so a point dot x and a point dot y are between 0 and the width. We need to make it so that they go between 0 and 10.
yeah.
So it's num rows. Or rows. I think this makes sense.
It should. A point
I
dot.
don't know if math again, dude, like, this is like, what's that?
We got the field, the vector there. I can just say add. Oh,
Yeah,
let's go.
it is working.
Let's go. But
That started at 0, 0. And let's see where it goes.
okay.
At least it's over. We've done that for good.
Yeah.
It's a bit too fast. Again, we update the velocity. That's why it's going faster and faster.
Yeah.
But I could try to go back with the. Oh.
So you're adding constantly, right? What if you reset the velocity after every point?
Yeah. So instead of storing velocity at all, just
Yeah.
directly update the point. I think that's why updating
Yeah,
the point might be
yeah.
better. Yeah. So I could use this line. Update it here.
Yeah. Now it's
Yes.
following the lines.
Oh, that's actually sick.
Yeah. Now.
Now you can add a lot of points.
Yeah, 2,000 points and 1,000 balls.
Yeah, and then initialize them at random
Yeah,
positions on
but
the
it's
screen.
balls and random points.
Okay. Smaller.
So
Or at least in a random top left.
yeah.
Not bad. Not bad. Now imagine a lot more. You don't have to because we have to do it now. Let's do it.
It's following the line where it's at.
Roughly. So.
Roughly.
Yeah. Is it?
So you see it goes down and then it goes right, it goes down and then it goes right, kind of. Yeah, it's like pachinko. Yeah.
We have a very bad code.
Yeah, it's actually so cool.
Very bad code because of these. So points is a list.
Yeah.
Now we have to generate a lot of them.
Yeah. Let's just make a loop that generates like 100 random points all over the screen.
Num points I plus plus. Then we can say points dot add. Since point is
Yeah,
just
we mentioned about loopies before doing it.
a vector
Nah.
and random.
Yeah, let's
So
do random.
it's noise again. It's
But
always.
no, noise will give you correlated points. If you want points anywhere on the screen, we have to use random.
Oh, there's a random all along.
That's what I'm saying. There's two different kinds of noise. There's random
Don't
noise
you
and
just want
sorted
points
noise.
to be like on the top left so that they can flow down?
That would also work.
I was
Yeah.
thinking top left with some noise like of where they spawn, like randomly like a certain.
Yeah. Floor it.
It might
Maybe.
be strange if they're spawning anywhere.
Okay, we generate a bunch of points. We
Yeah.
push it to our whole array of points, right? This is where I learned my first array. I don't understand array, and this is where I learned it.
Yeah, so
It's pretty awesome. Now, we draw the line. We don't even need this anymore, but we're just gonna keep it there. The cool part is here. Instead of just drawing one point we have right now, we draw a lot of them. And the way we do it is, again, loop. So start from 0, and since we know there's numbers of points that we can use, we're just gonna iterate through them. We don't have to do this. We can call this function outside. This is just for P5 to know that from this point on, whatever I draw must be this way. Have no stroke, and must have a fill. A fill is like
yeah.
the color inside of that. Now I'm just gonna say const p is equal to points at I, and then instead of just call that, I can just do this. P. There's a lot of weird math, but it's all just intuition, like what you want, and then
Oh, they go outside the bounds. So fields and
Oh, yeah.
floor, that is outside. So you can add an if statement to just, if that is true, just don't do anything, get rid of the point.
If-
or don't draw the point at all, right?
What I could do, if the width or height,
Yeah, if p dot x and p dot y is greater than width or height.
if it is larger than width, I can randomize the width back in.
Oh, true.
Right?
Reset it.
Yeah.
True.
It's not actually reset. It's gonna be so messy though. Anyway, p dot x is equal to random. Multiply with width.
And then height is the difference.
Yeah. If p dot y is larger than height, p dot y is equal to random. Multiply with height. Just to random gives you 0 to. Oh, okay.
Now
Zero-
we're getting there.
Yeah, we're getting somewhere. Random it's got this like a dense kind of thing down here. What we want is maybe just throw it at the top or
Or
something.
at the top, yeah.
Or
Yeah.
maybe not even like.
So instead of width, yeah, just do times that.
Let me do more and more.
More.
More points, yeah.
Give me more. I need more.
And then I would say,
You see the flow, right?
Lower the thickness of the circle.
yeah, lower the thickness of, or actually, you can,
Speed up.
again, do what we did earlier, change the thickness of the circle, change the radius of the circle dependent on the velocity at that point there.
Oh, it's way too small.
Yeah, change the radius of the circle dependent on the strength of the field.
Ah.
So as it
So-
moves faster, it will go bigger.
Mm. Well, there's no velocity. It's just the field.
Oh yeah, just change it as the field there. So
What is happening over
instead
here?
of 3,
Have a good day. The record will be on Discord, so you can continue if you want.
yes.
Magnitude.
Yeah.
Multiply with 10.
10 is too much.
Yeah, something about this.
7.
Oh, we try to calculate first, but the checking must
Yeah,
happen.
yeah.
Like, oh.
10 is too much, I think.
Yeah.
And also, so instead of circle, what you can do is change the stroke and make it lower opacity.
Sorry. Wait, what?
You can change the opacity of the circle as well, depending on
Based
how
on
fast
the
it's moving.
velocity.
Yeah, that you can do anything depending on velocity. Now that we have access to the variable.
Yeah, but the problem now you can see it's accumulating
Yeah.
because our field is not randomized enough,
Yes.
Yeah.
right?
We need to amplify the noise.
Eventually, it will come to a point that keep going on the same line. Any idea? We could just try to. Well,
Let's try amplifying the noise.
are we sure we understand this? Oh no, not that. This. Does it? How does it noise actually work? Because it seems.
Yeah.
I could try negative 100 maybe. Will it give me something
This
else?
won't make a difference. This will be the thing. So that is just a seed value.
Yeah.
right?
Yeah.
And the thing with Portland noise is that the seed value is dependent on, or the gradient of the noise is dependent on the difference between the seed values.
Yeah.
In this case, even this one will eventually go down to the thin strips. I think what we might need is more noise. Upsample the number of
What
rows
if
and columns you have.
what if I do this? Random. Do we need Perlin noise at all?
Yes. Now they don't follow any
But
pattern.
I could try to do the average
Average of what?
of like convolution of the thing. So convolution will give me the average, the neighbor. So the whole thing kind of.
That is what Portland noise does.
Okay, let's do that instead.
I would say try increasing the number of rows and columns you have.
I see.
Right? Because if there's more vectors to influence, there will be more
I see.
like
That's what I
channels.
wanted to say all the time. More.
Yeah, more.
One is 2 rows.
But it does give some interesting. Another thing I want to do is x and y is just row and column, which is so close to 0.
Yeah.
So what if we amplify those? So it would be spread out a bit more on the terrain. Yeah, there's no falling.
What?
Does it generate only from 0 to 1?
It does generate 0 from. So what you can do is add a random value that flips the sign.
But what if I just shift them?
You can, yeah. Oh, true.
Okay.
Yeah.
Something not right.
Magnitude.
Huh.
What?
Have no idea.
This
I'm guessing that
this
it's
made it not a vector anymore.
Oh.
Or the magnitude is undefined.
Oh, I think, I know, I think, so magnitude is square root, so I think some of the value, all of the values will zero.
I thought it would go negative.
Or negative, yeah.
That's what they should
Oh,
be
I see.
But it's square.
It is
It
square.
shouldn't
It's not like
Wait,
square
but
root.
magnitude.
Magnitude is just square. It's not square root.
Yeah, magnitude will work on
Yeah,
everything.
it's square root
Square.
of the difference between y and the.
It's always positive.
That's a distance, but you just have 1 point.
It did look like this, like
Magnitude.
It should always be positive. How is
It
it
should
magnitude?
always be positive.
Yeah, the 0 minus like y squared plus x squared.
Yeah, but y undefined, that's still.
yeah, it's
It's not a vector anymore, I think. Something, I don't know.
0.5.
Wait, where was the line? It's here.
Yeah.
I'm gonna check the recording real quick. Still recording. Is it? Yeah.
Is there a reason all the points are flowing that way? Like even when they seed all the way back? Because we're randomly seeding them to the top left, right? Why are they?
Because velocity is always positive.
Wait, go back down to when you reset the x and y of the point. P dot random times 10. I think times 10 might be too small. So all of the points are going to the same area and then following the same one.
I see.
Maybe spread out the reset value of the point, because when you initialize them in the beginning, they're all over the place, right?
Okay, let's make it all on the top.
But
No, the problem is
I
not.
think the direction is because.
Yeah, the-
velocity is always positive.
Yeah.
Yeah.
What I was thinking is, what if we don't generate a vector but generate angle in the first place? So, and do some weird trigonometry math just to get the
I would
vector.
save that code.
Sorry?
I would say like Unreal save the
Yeah,
code
save the-
and
Oh yeah,
Yeah.
common, boom.
There's no game.
Random. I could do random, or that's fine. Random for now. 2 pi, right? I get an angle. Now I can convert it to vec x, which is cos of angle. Y is sine of angle. But this will be, yeah.
Oh.
Oh, okay.
Now you probably can't find 11 where
Line 63.
63 is
Huh. Oh, it doesn't even exist. I think we forgot to push it. It's pushed. Here.
oh, it's is it 0? We are pushing it now.
Yeah.
What changed? You changed it from the noise to the check.
Wait, let's put it back. Let's put it back.
Current undefined.
Huh.
So what is the
Yeah.
is cos not cos is returning a vector?
No,
It just
it just returns a value.
Oh, okay. Oh, you're okay, okay. So you're doing a random angle.
does it take degree or radian?
Radians.
Mm.
I think it's radians.
Yeah. Where's the
Oh, it's takes into account the current angle mode.
where is it? Where? Where's the angle? Oh,
By
here.
default, it is. I think you know what we're in the current angle mode, which is either radian or degrees. You can just print angle mode.
Yeah, just put it to radian anyway.
Yeah. It's still
Hmm.
undefined. Reading 14.
Okay, we got the vector. Wait, the error happened before the vector printing, is it? Or is it just put it on top regardless?
I think it might be an indexing problem.
We already know the size of the vector. It's happened
Like,
now,
scroll down.
and then I think after the first rendering, something went wrong.
I think it is a problem. It is an indexing problem. I think where like float py divided by rows and float px, one of these returns a value which is like outside the bounds of the array, which makes it return undefined.
So let's say my
So
y
that
is.
our logic here of floating it is wrong.
Yeah. Wait, so if I divided that, it will give me 0 to 10, right?
If yes, py exists between 0 and call rows, 0 and rows, we divide it by the number of rows. So that puts us between 0 and
Give us which row it
rows.
is.
Yeah, it should give us. Try. Okay, what we can do is instead of dividing it,
Try
try
to
modding it.
Oh,
Get
yeah.
the remainder, so it's always between number of rows and number of columns. No need to do any floating.
Yeah. Oh.
Then back here is still undefined. Oh, it's still undefined. Go up, like all the way up, where we define field. For every row, for every row we have a temp value, so we should have. Oh, for every what? We have temp.
But why does if I do this it work?
Because this somehow is in the bounds.
Oh. But it says that the accessing on the field alone is the problem.
I think so. Like the field returns to you an undefined vector.
So it's probably one of the codes that give you the error value.
Actually, wait. Go down. Let's just debug this here. Before vec here,
Yeah.
initialize two variables for vector index. So vector index row and vector index column, and then just print them, and then see what values cause the error.
Like rows and column.
So print vec row and vec column.
Oh, there's a function called print.
So
Negative.
negative 116.
Oh, it's here. It's probably something about that.
Yeah.
We generate it, and then how
Do
do
the
I?
same for height. Or just add. Wait, these are random.
One of those is negative.
Wait. We're using sine and cosine, right?
Yeah.
Their range is between negative one and positive one.
Oh, now we didn't have a
Yeah.
we didn't have a check condition for negative part where it go.
No, you don't need
No, the vector is fine, right? We want it to go everywhere,
Yeah,
Yeah.
that's what I was
but the
saying.
point will flow that way, and we didn't check.
Yes.
The negative
yes.
part.
So do you reassign it?
Yeah, that's funny.
Okay.
Just or.
Yeah.
Programmer, right?
And then same for height.
Yeah. Now I can initialize the point. Oh, it's so laggy.
Yeah, maybe just don't.
Yeah, what's happened? Oh, printing, printing, lag.
That we're breaking it? Ah, yeah.
Yeah, the printing. Oh, it doesn't go anywhere. Okay, the flow.
Because
What if where's the part we add? We add it here. We do a multiply. I cannot just do that. What was it again to multiply it? By a super small number. This is like gradient descent.
something happening, yeah.
Super small, too small. I think this is where we can start using velocity again.
Yeah.
Okay, let's do that. Oh no, the velocity. You need another array for velocity now. That's why we need a class point class.
I would honestly suggest save the code before we do the angle thing.
Wait, what?
Like before implementing the angle thing, the code we had just with vectors, just save that. And like have a copy of that code.
Alright, it's too late now. Let's go with the flow.
Okay.
I'll change the code if someone need it. Velocities is a zero vector. Are there a function to create zero vector directly? Now I create that. What I could do is, for each of the point, I get the velocity at the same time. Of I. And we don't care the velocity reaches zero or not. what we do care is adding, could just add it first before we even draw it. Simplify everything. Well dot add fact here. Okay.
Oh my god.
Okay. When we reset the point, we can reset the velocity too.
Yeah.
Or I could do just access the x and y. It's feel weird to do this on pure function thing, where you change stuff. Okay, that's fine. Now all I need to do is to make the vector a bit smaller.
Wait, instead of doing random times 2 times 5, do noise times 2 times 5. Actually, it should give you the same value. Never mind.
Wait,
Moving through it, it's the same value.
it might be similar though.
Brackets. Okay.
Forgot, my bad. Y is in x times 0. Oh, no.
Yeah.
Does it actually reset the... Huh. Anyway, this... Yeah, it should be 0 to 1 already. Even smaller.
Ooh. Now it's something.
Yeah, but it's not the way we wanted earlier anymore.
I think that's because we're using random instead of
Yeah.
Polar noise.
Alright, let's do Polar noise again. Oh.
That's kind of cool.
That's kind of cool, yeah.
It's like Starfield.
So you can make it look like Star Wars, make it look like
Yeah.
if you make it go down.
X and Y. It's weird, it's only one direction, it's always.
Yeah.
Oh, I forgot, we should spread out X and Y a bit. Wait, how do we spread this out?
Just add something to y, then one variable.
Never mind, it
So
doesn't.
this is just one generated value, right? So it will just give you the same thing, I think, every single time. It's only being generated one time. So it doesn't make, I don't think it makes a difference whether you use.
No, but this thing is being sampled on very close together on the same terrain.
Right.
That's why the value. Oh, that's why
Yeah.
initially the noise alone here.
Yeah.
That's why I was sampling it and everything worked. Oh. No. It's a bit slow. Still just keep going that way.
Yeah. But to be fair, if you look at the original Pinterest post that we started with, it's all going
So
one
off.
direction.
yeah, but it's so off.
Yeah.
Oh, what we could do is use a downward vector and then randomize the x of the vector. So the vector has a downward y and then the x is randomized.
But again, you won't get these channels, like thick channels that way. I think the reason why these thick channels occur is because all of those flow feeds from different directions converge down into
Yeah.
those streams.
What does this look like? This is like us.
Yeah, it's kind of like us.
Yeah, try to look for the one that look crappy. My computer cannot handle it. I can cook some eggs right now. Alright, more points. As you requested. Wait. I could, where was the row? I could just simplify this. And then add more point. Does it even matter?
Yes, because the number of vectors you're calculating is smaller now.
Okay, let's go back then.
But you will get less smooth transitions.
What's happened? I think a way of sampling this pollen noise is without using velocity should be fine. We don't have velocity.
John, are you still getting on today? The weather is so dreary.
I think it's fine now.
No, it's getting worse. It's supposed to get worse.
Tomorrow is gonna be hotter, right?
Tomorrow's gonna be like 20 degrees, 17 degrees.
There's no way.
I swear to God.
It's gonna get worse right now.
Yeah. That's why I'm just like,
Last day of winter, you know? You just have to go out in the rain.
it's just like,
It's always.
I don't know. There's going to be freezing rain. It's just been snowing. Now it's weather rain.
Wait, what if you take the noise
Yeah.
that's being given to you between 0 and 1 and you extend it, you map it between -1 and 1, right? So now you get a negative direction.
Yeah, that was what we did. Hey, wait, did we? No, we did
No.
not. Yeah, minus.
This is still skewed,
Sorry?
What's going on here?
right? Because if you multiply by 2 with -0.5,
Yeah.
it's still skewed.
Skewed.
Why do you multiply by 2?
Because it's 0 to 1,
Yeah.
and if you shift it by 0.5,
Yeah.
it's just gonna be negative 0.5
Oh,
to 0.5.
okay.
So how should we do that?
But if you multiply by 2, shouldn't it be -1 then?
What's happening here? Why are some of them not?
Yeah, from -1 to 1. Yes, one of those are 0, I think.
So
Oh, we
this-
shifted.
The range is
Yeah.
Yeah. So how do we like make it not closer to 0? Like how do we make the generated number not too close to 0?
so the noise function gives you between 0 and 1, right? So all you
There's
have
a
to-
map function.
Oh, there's a function for that.
Yeah, there's a function called map.
This is crazy.
Oh, but the idea is that
Yeah.
after we map,
Yeah.
there will be more like because of the normal distribution, something close to 0 will be more, and it will generate more closer to 0 number.
Yeah. So
And-
what if going back to my original point, what if we randomly change the sign of the noise, sign of one of the vectors?
I see. Alright, let's do that. Multiply with random larger than 0.5.
What?
How does it give you that?
So that is,
Negative.
Yeah.
Boolean is, yeah.
Yeah. This is janky code.
Yeah. Now it's 50-50. So it's just staying in place. It
Wait,
cancels out.
I still do want to try pointing y downward always.
Yeah. So don't map y to be random.
Just keep it positive.
Yeah.
That's it.
Now it's dribbling back and forth.
I
So
see.
change the threshold for 0.5. Make it 0.8.
But it would go to the left more.
Yeah,
Yes.
it will go.
I think the way we update this is too quick. It just keep.
Yeah. I think lower the velocity, increase the amplitude. So it jitters more, but moves slower.
Just randomize, so -1 can be amplified for more, like how
I could do it out here. So it would go left to
Yeah.
right more. Is that?
But now reduce the influence of velocity.
I see. Oh, the circle messed up. Withdrawing by radius. Where is it?
What? It's moving straight down now. We were trying to make it good, so what we
Oh,
found
can you
is
also make like
everything
the
was
Y
moving that way.
noisy, but
We
it won't
wanted
be
it
positive.
to be sort of
So that would go in a direction,
Yeah.
but it will also have the
yes.
movement in
We
Y.
don't really know how to do that, so we're messing around.
Okay, that's not.
It looks like it's rotating.
Yeah, it does.
We're seeing things, guys. We're seeing
We
things.
are seeing things. That's kind of cool.
Dude, that looks like so
Ooh,
fun, though.
this is kind
Because there's this weird
Let's put-
interval between them.
What if we add more resin palms now with this? Like
I think that'll just decrease the gap between the points.
No, the sampling is a bit more diverse in a way. Is that what you're saying?
No, you say
Like, I'm saying increase the number of resin, number of palms.
Oh, let's do it. Oh, it's already 50. My computer is dying. Well, I guess it's not bad because
it's
it
the same, but with more
Yeah.
Look, it's
Yeah.
like stabilizing too.
now the period, it's kind of sine wave, you know, like
yeah, it looks like
it's
a
bigger.
weird double slit experiment.
Yeah.
It's I also
or we
did
could
the
do something related.
tuning for
Yeah.
what
Like-
they call it? You know the waveform that
Yeah,
I'm
yeah, yeah.
tuning for? What do they call it?
Sine wave,
I don't know. Like it's a different
frequency,
No.
natural, whatever, atom
What are you looking for?
simulation. It's like one of those they want to show that atom is not a point using this wave
Oh,
function
yeah,
thing.
yeah. Look up is it- look up double slit experiment.
Yeah, but I just want to show this. There was a guy who instead of just this color, he generated like a bunch of 3D point, and it's like a cloud, electron cloud, I think. Let me do this first.
all electron cloud. I think they ionize the or is it a different thing?
Like this. That's fine. What was a double split experiment?
Yeah. Double slit, yeah.
Slit.
Same.
Yeah.
That's what our thing looks like.
If we go here, there will be something more artistic.
Yeah.
Skirt. Oh, it's not. Well, I guess we don't spend too much time trying to make things beautiful. We
Yeah.
just this one, it's nice. Anyway, what are we doing? What am I doing?
I mean, this is weird for me.
Let's put back velocity.
We'll put the code out. Do what you want with it.
I bet ChatGPT can make some cool stuff.
Yeah.
That doesn't count as generative art.
It's generative Jennifer.
Yeah.
It's generative square.
We don't randomize
This is actually
height.
the process of making
Yeah.
around.
So we just always start from the top. Oh.
What the hell?
Oh wait, it's actually
That's
very
right,
good.
I can write
Oh,
this.
that's like rain.
Yeah. Wait. How do we lower down?
Messing around with some values.
Can I get a version of this?
Like right now? I can send it to you. But I'm recording, so they might see
Our very financial.
we have very beautiful chat. Yeah, why is it?
What?
I don't know what I'm trying to do, but something's not right. So many comments out code.
That's what I'm saying. You should have saved the code.
Yeah.
Oh wait,
We should add that first, like,
I should have
yeah.
plus it. Whoa, that's crazy.
Ooh, I have an idea.
Yeah,
Assign a point to random color.
let's do that. Let's do that later.
Oh, cool, that's cool.
Let's do the color. I do like the color.
Yeah.
That function maps the value of the noise
To-
between your range.
Yeah.
It can map any value between any range.
So 1 to 0 to 200
Yeah.
to 500. So it's like a fancy way of multiplying without having to deal with
exactly.
min and max.
You know, map it and try to make randomize or totally noisify
Yeah.
massive characters.
There's random. You can kind of tell the random ones are like just spawning out of nowhere.
Wait, is it?
Yeah.
Yeah.
I thought put
Because
y.
they're spawning from in the middle of the screen, not at the very top.
I thought I put y to 0. If it, you know, that's
Are
weird.
they spawning out of nowhere? Why?
Yeah.
No, they are.
I know.
Unless they're just changing direction very abruptly, but that's not happening.
Yeah, but this happens only if
Cariño.
I'm gonna make some.
Yes,
I didn't think I was
please,
going to, but I have
please.
Swiss so
What is this? When are you guys
As long
saying,
as how good
on
it's
Sunday it's over?
it's valid.
Next Sunday.
Next Sunday?
Next Sunday.
Oh, it's lots of time.
As long as you like have a code that can draw it, good enough.
It doesn't have the.
What? The channels?
Yeah, the channel.
Yeah, because we got rid of the channel like 5 iterations ago. And next week.
even more radius.
I mean, that has to be enough. If you even give us the raw code, we can run it.
So slow.
We do have data, yeah. But
Instead of starting here.
That's your code, that's your apology. One of the cool ideas I had about this donor thing, I was thinking about it.
Still some work left
Depends on how you want to approach it.
because we wanna host it.
One way you could do it is,
But that's not
let's say I have a
remarks.
upper marks donor.
We think so far, why not?
Yeah, you should know that we're gonna take care of these.
If you, there's a way to do this without doing any math.
Did someone say math?
If we go here and we get the donut, where I save it, donut, right? What you can do
I
is look at how bright every pixel is,
We update
right?
y.
Yeah, you can get the number of pixels right here. This gives you that. This gives you exactly the number of pixels.
Sorry?
It gives you direct access to the pixels.
Take reference.
So you just
I don't know.
check how bright
Like,
it
how
is.
do they get it?
So let's say we can do threshold operation. This will select all pixels that are bright.
Oh wait, what? Upward now?
Now we have a donut, right? And we can
It seemed like going
tell
up is like
how bright
constant
we want
speed.
our pixel to be, right?
You know, like
Because
going on your
now
axis
the
is
thing
constant.
Depending on how bright the pixel is, we pick a denser looking character. If it's something
Yeah,
that's
these are.
really black,
Why do they look so cool?
Yeah. So it's like constant speed, while left and right is a bit more dynamic with the velocity and all that. So I'm gonna try that.
But yeah, those go back.
Right?
I don't. Okay, are they going up at a constant speed?
It looked like it. It doesn't speed up, right?
Yes, exactly.
The only thing that make it more dynamic is the left and right, and we need velocity for left and right.
So here's the thing. In some places,
Yeah.
you see the dots moving diagonally, like at an angle.
Yeah.
So that's the thing, right? If you do
Those
it
are-
if you do it this way, we can do any video.
Okay, yeah.
Wait, I'm gonna try something.
This could still be like a.
P dot x is equal to plus well dot
Yeah.
x well p
Exactly.
dot y plus vect here
Yeah.
dot y.
Any image.
Wait,
If we turn into text.
Oh wait, I could just add it by a constant amount.
Yeah.
Yeah. And instead of, depends what you
It's
want to
getting
learn
slower and slower
rendering,
and
then
laggy.
that's probably better to do it, like the math behind it. But if you want
Okay,
to
I think
learn
you're on.
image
Like
processing,
you were right about
this is better.
the Y,
Then you work
because
with
it
any
looks.
and
Now we just
filter.
need to somehow make it
There's a
stuck.
filter on an image. Grayscaling is a
I think
filter.
just.
I think the
no
way we
random.
randomize.
Yeah, randomize.
Oh, we
is-
flip it. That's
Edge
why.
detection.
Wait, let's draw the field again. I think the field doesn't look
Once
great
you have
anymore.
access to the pixel value,
It's looking kind of weird.
whatever you want.
Yeah. Oh, okay. So
And
because of that, the
filter
ball kind of just
can be
bumbling
done
around. It
anywhere.
doesn't have any.
What do you mean?
You see,
No,
some of those just.
let's have some.
Wait, let me try something.
Because okay, all of the dots are still like following the lines, the
Right,
lines.
and then we have, I guess, depending on the size
Does
as
make
well,
sense.
right?
Oh, all
Then
we need
have
now is a way of it
this.
to
this
be between 0 and 1.
right? You can probably find characters sorted by
It doesn't make, it's the same thing. It's the same thing.
or rightness.
Gario.
Rightness as the characters.
Those things are
By
like-
rightness.
Sorry?
If it does that,
What I could do is x multiplied
take
by
the fixed value which is between 0 and 255. You have a number between 0 and 255. How many characters do you have? And that's the 255, right? So you map it, you take the number in that range, map it to this range, get the character, and wherever the pixel is, write that character. You take a number, a pixel value between 0 and 255, that has to write a pixel is, right? Then you take a number in that range, squeeze it down to this range, so you can use it as an index for this character, right? Get the character, display it on the screen. Do that for every pixel. You have the window. Right? The exact same thing happens with every other picture. If we look at thresholding, I go through every pixel and check if that pixel is greater than this number. If it is, white. If it's not, black. There's no math. It is greater than less than. That's still math. And then same thing with grayscale. Now, an image is made up of two channels, red, green, and blue, right? A grayscale takes all those three values, so you get the average. If you have a fully red, a fully blue, and a fully green image, that's white, right? And white is your brightest value, right? If you have 0 red, 0 green, 0 blue, that's high color, that's black, right? So if you take the average value of all the brightness of each of the channels, you'll get the gray value, the brightness value of every pixel. That's all what this filter is. Right? Inversion. Take every value, subtract it from 255. Invert it. Yeah. You're flipping it. The maximum value is 255. If I have 100, like a pixel value, the invert of that is 255 minus 100. So the right values go all the way down. Because the right values are closer to 255. They get mapped all the way down to 0. And the alter values, which are closer to 0, get mapped back up to 255. That's how it works. No. You just think about what grayscale. I really looked at Wikipedia. Image inversion. Invert color. Wikipedia. Flip image. This is image not nice. I don't even think I looked at it. I googled what is image inversion. I don't even know where I found it. But anyway, the names aren't right.
Oh, that somebody wrote the exact code for vector field generation.
Oh yeah.
Oh, wait, what? Never mind. Doesn't look correct.
Yeah.
Gravitational constant, let's give it
Most likely
10.
anyone would any code you write, right?
Oh,
Was
whoa, whoa, whoa. Whoa.
What did you do with the button?
There's no button.
Oh, Jack.
Oh, it's that's cool. It's a 3.
That's so. That would be so simple to make as well.
Oh wait, I think I know why our field doesn't look great because I don't know why, but I think what we could do is generate a point, a random point here and there,
Yeah.
and let our field try to direct to the closest point. Generate a gravity closest, try to.
Now you want to do gravity. We don't have time for that.
We don't?
There's 20 minutes left before we do
yeah.
gravity.
Okay.
I would say, do we have the code? Where's our code?
I wish you had that original code.
Yeah.
It's-
I would love to branch off that.
It's raining now, but Control C.
Okay. Oh my god. Okay, you're getting rid of all of it. Save this.
I have to say save this.
Save
and then
this,
just
and then go all the way back again.
Yes.
Okay, I'll
This one's cool too. The rain.
I just know what it is.
We can go back back in the recording.
Yeah.
Copy of the
If you
automatic.
want.
You break it down into simple problems and you combine all these simple problems and you get a product.
Okay, okay, okay.
Yeah.
I might have an idea about the gravitational field. See that they have like these uniform. Wait, let's look for somebody else's code and see if they have.
Because I would assume everyone's trying to generate the donut input. That sounds different.
Oh,
I
this
would
one.
not do that. That's what I would suggest.
Oh, that's cool.
It's a bit more uniform
Then
than.
thinking of it a different way.
Yeah, they use a angle.
Oh, yeah, go ahead.
They generate angle before instead of x and y individually.
Yeah.
Anyways.
Well, you're still gonna be using math. Yeah.
Not even angle.
Yeah, yeah, yeah. Yeah,
I got an idea. Let's see.
That's not that bad. I do that. What are you trying to do?
I saw this. They use an angle, but it's predefined. What I was wondering is instead of these, how can I?
You. Why even have the
Sorry?
noise there at all? The noise over generates randomness. Like if you want this uniform periodic thing,
Hmm.
you just get rid of the noise.
Whoa. All right. Let's go to this code.
You're
Just
not using any noise.
inspirational. We're doing it. Let's visualize the field. It's too uniform.
Just reduce the number of rows and columns.
Oh,
Scale it, like zoom into it. Yeah.
They translate, my bad. Here. For some reason. Oh, it's slowly copying the code. We have to set the magnitude to a certain value.
Maybe next one is
Y minus x. Nothing
What are you
working.
doing?
I used the exact same code. Set magnitude might be a thing. Oh wait. It's based on S.
What are you doing?
Oh, this is just scaling. It's normalized and then it's scaled to a certain magnitude. I gave up. This code.
We had. I think we lost. We got lost in this house somewhere.
As a program, I've stolen so much.
Alright, let's look for somebody else's code. Again.
It's open source, so you can
This one. I think the vector field itself need to be generated like as a velocity thing, like you have the change in thing. So you start off direct down, and then you slowly walk through each of those and then move it around.
What do you change it based on?
I don't know. Let's see.
That's the thing, like, you don't have to do that because Berlin noise does that automatically.
Yeah. But it doesn't seem like you get the sweet spot of their
Yeah.
parameter, you know, like what are the
Okay, I have an idea. If you can bring it back to the Berlin noise generator thing,
yeah.
I have an idea.
Alright.
Instead of pouring points down, let's draw lines flowing down. So at every place where a point is, let's draw a line.
Here, right?
Go back to where the flow field is generated not by sine or cosine, but by Berlin noise.
Oh, okay, we're simplifying this again. Vect x is equal to noise.
Oh yeah, so random. I switched back to I switched to lazy mode.
La-
So much better than I don't know. It's nicer. It's easier to act on.
I don't. I should know how to like change my configuration on each other.
Yeah, you're not supposed to. It's supposed to be like
Yeah.
as is.
There's so many cool things I found about like Vim. They're not in the game. I showed him. They're so insane. Vim has autocomplete built in.
Oh really?
Yeah. It's so big.
Lazy mode is LSD that's like turned on.
Yeah.
On.
That's what happened.
But I don't. I agree.
I think a polar noise only work in 1D, and we're trying to generate a vector
No, no.
because the whole terrain has three value, right? X, Y, and then
Yeah.
t. But and then the result is just one scalar number.
Yes.
That's the thing.
That's why we offset y.
Yeah, and once you offset it, it doesn't matter. It doesn't mean that the different part of terrain will have similar x and y anymore. It doesn't.
If
Have,
you move in the same direction, then they will. It still works out.
As hard as you make it for yourself, though. You can make it easy for yourself.
You can just get away with the bare minimum.
I still believe in this.
Yeah, that's the thing. Like, when you promise the Jenna, I'm gonna do this, and you don't have to, that's extra work for no reason. And then Jenna expects it, and you don't deliver, then you get bad. That's why. That's the thing. Jenna has to prove it.
If you log your code.
Like Jenna.
Oh.
Say, I want to build this, and then Jenna says yes or no, or she'll act like it's doing it.
So angle is a
Yeah.
single number, and then you can use that angle and to generate the 2D vector. The vector. So
Okay.
polar noise only work on scalar,
Yeah.
and if you offset, it doesn't mean that it's gonna work, right? So with this, we can now
Okay.
put it back. Oh, velocity gone, 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 back, gone, gone. Hmm. But at least we got the
Yeah.
noise.
Yeah. I would say instead of points, or like not even increasing the number of points, what we can do is trace the path that every point takes. So make a point, draw a line, and the more lines of
Yeah, I got it.
you get what I mean?
The detail also matter. Now,
Yeah.
now you can see it's a bit more. I think the way we update it is too fast. Like the magnitude is a bit too big.
Yeah.
Like right
I
here.
think you can like multiply by.
That's fast. Still too slow. I think the way they visualize it is that one axis has a constant speed. So like if you want to go to the right, it just keep going very strong. And then it's being influenced by all of these. So I could say that vector
I know I'm looking for an all-nighter like tomorrow. Just adding the right.
Your chunk for your
There's a couple of extra features which like they're there in the back end, but there's no buttons for it in the front end, which I need to add.
When is this project?
I don't know.
This Friday, the final caption. They already presented today the final caption.
Yeah, it was insane.
Oh, it was good?
It was really good.
Yeah, I just saw them working demo and it looks really good.
You guys look for Mars.
We didn't get the marks yet.
Gary, you
It
also
must
can't
add-
get below 90 honestly. Or you can't get below 80 and you can caption.
I mean, whatever we promise, we do.
Yeah, same with us.
Yeah.
Everything we
I'm
promise.
just disappointed with
Thank you.
I'm just disappointed with the animations that I thought I would have.
You guys are just building the most viable products. Like, if you want to make it better later, like that's up to you. But like, just for capstone, you did what you were supposed to do.
We do have plans on making it a little better.
what were you saying?
That's good.
Like I said,
I was saying trace the path that
Oh,
everyone
yeah,
takes.
yeah. My bad.
That way you'll get the
Wait, how did you
the
do
same
it?
what?
I generate using angle instead of. Is it 0 point?
What the hell?
With this was
That was better.
Yeah.
this inverse everything.
Okay. Oh, you can see the trail. Look at that. I don't want to say that word. It looking like something.
Whoa!
Oh, whoa, whoa, whoa.
Motion blur?
We reinvented
Wait,
motion.
what is going on? What did you change?
What did you do?
I changed the
Oh, you changed the opacity.
reset opacity to very low.
Wait, that's it.
Oh, that's cool. Oh, this could be so.
Oh, it's getting.
This is trippy.
Okay, something not right.
Why is it only going that way?
That's a good.
Oh, it's because you have vector addition, I think, at the bottom.
I remove it.
You okay?
All of these has an influence toward a certain direction. Sampling it closer together will give you something more interesting. But too close might be not very interesting at all. I could do this. Now it's just some random squiggly line.
That's cool.
Yeah, it's like matrix.
The matrix, yes. Yeah, all of these points just follow a certain line. Something ain't right. Oh, it's too close. What if
Yeah.
we resample all of the vector field over time?
Yeah.
Oh man, why do I? It's
You,
like-
you can, no, so what you can do is use the frame count, mod it by some value in order to reset it. You have a thing that iterates. You have a stop counter, the number of frames until you want to generate.
Yeah, but-
and after that, just
Mm.
random again.
Technically, we don't even need to store this vector in a 2D array, because Perlin noise is
It's
deterministic.
deterministic. Yeah, yeah.
So this x and y give you the angle and vec2 already.
Yeah.
I could just reuse this with the. Yeah, I see.
Yeah. But wait, I would suggest there's 5 minutes left. Go back to the cool thing. Yeah.
All right, which cool thing? Which cool thing?
The one where you were changing the opacity.
Yo, what's up? The point to stop. Okay, cool thing.
Yeah.
Oh wait. Oh, we still haven't.
That's so cool.
Yeah, honestly,
Deal
anything
with
here is cool.
color.
Yeah. Oh yeah. If you want, you can like randomize the color. So as the point moves down or whatever, like change this color
Just this for now. We don't have time. Whoa, what?
What the?
Huh.
Whatever they go.
That's a math.
I got no idea.
Oh no, this is luminance value between 0 and 1. That's why everything should go
What
to
do you
0.
want to do?
Trippy. Whoa, whoa, whoa.
Okay, wait, I have an idea. What, instead of this, fill it with x comma y comma 0.
This is outside, so I see.
Just do it inside. Like right before you draw it.
To put it
Fill it with p dot x and p dot y dot 0, comma 0.
so same.
Doesn't have to be. Don't make it noisy.
Wait, what?
Like get rid of the noise altogether,
Oh,
and then change the value. Yeah, so red channel will be its x value, green channel will be its y value, and then blue thing should be 0.
The whole time?
Yeah.
Oh, that's crazy.
Or 255, I think.
oh, we have to use map now, huh? Oh, I don't want to learn that yet.
For some create
This thing is between 0 to 400.
Yeah.
for some created Next.js.
Now we multiply it back to.
For some create Next.js.
Not sure.
I think they did because that's why they're because they're cheaper on Next.js.
I mean, I have a couple React projects, but I don't know what it's probably the
Yeah, I mean, for some they create Next.js.
Okay, never mind. I don't know what's going on here.
I kind of see blue. Oh, 0 is too bad.
Okay, we gotta go though.
Yeah.
Yeah.
Okay. You can get rid of the color part. Like for now, just make it black and white. I think that's cool. No, the tracing part, you can get rid of the fill. Yeah.
Put the code in the Discord as well.
Sure.
Why is it brown though? That's like the worst color for this.
What?
I don't know, it's like I feel like it should just be black and white. It's so
Wait,
random.
why? What? Oh no.
Oh, it's inside the loop now. Make it outside the loop. Earlier it was outside, right?
Wait, what?
Oh no, it isn't.
It was outside. No stroke.
there is next.
Oh, the stroke. The stroke. Just
Ah.
delete everything. Okay.